Hi my dear children, this is Prasanna, your maths tutor. Dear children, in the previous video, we learned that how to find out the perimeter of closed figures, nothing but 2D shapes. In this today's video, we are going to learn how to find out the area of closed figures. So dear children, see here, the flat surface that you are seeing and which is extended infinitely in all direction is called as a plane. So best example for a plane is a blank white paper. So white paper or a blank paper is the best example for a plane because which is so thin and which is so flat. And let's consider this first shape. So what kind of shape it is? Anything which is drawn on paper or anything which is drawn on plane will be called as a flat shape. So right now this is the flat shape, and just look at the interior of this flat shape. So this flat shape has taken some space inside it. So this space which is taken by this flat shape is called as its area. Let's move on to the next picture. So this is again one more flat shape, and when you look at into the inside of this flat shape and the amount of space which is occupied, the amount of space which is taken up by this flat shape is its area. Similarly, area of this flat shape is this much and this much, and area of this flat shape is this much and this much. So area can also be defined in another way, that is the amount of space inside this shape. So just to see here, so this is the amount of space inside this flat shape, and this amount of space which is occupied by this flat shape is nothing but its area. And area can also be defined in another way, that is the amount of space covered by a closed figure. So these all are closed figures, these are not open figures, so these are closed figures, and the amount of space which is covered by this shape is this much. See here, this is the amount of space which is covered by this closed figure. That's why this covered space by this closed figure is called as its area. So area can be defined in three ways. One is amount of space a flat shape takes up on a plane. So this is the plane, right? This is the plane. And it can also be defined like amount of space inside the shape. So this is the amount of space which is within this shape, and it can also be defined like amount of space covered by a closed figure. So if you consider this one as the closed figure, then the amount of space which is inside this or which is covered by this shape is its area. Well, now let us try to understand finding the area of these closed figures. And so these are the some of the closed figures, and can you tell me which of these closed figures has the more area? Which of these closed figures has the less area? Just by looking at these figures, it is not possible. So in order to decide which of these closed figures has the more or less area, so we need to find out areas of these closed figures. Then only we will be able to say which of these closed figures has the less or more area. So to find out the areas of these closed figures, we need to place them on a square paper. So this is your square paper, and where every square is measuring 1 centimeter length and 1 centimeter breadth. So this is the square paper, or else we can call this as graph paper as well. So when you place these closed figures on these square paper, now you will be able to find the area of these closed figures just by counting the number of squares which are completely covered by these 2D shapes or closed figures. So but before doing that, we need to follow a conventional method. We need to follow a common method, that is, if the squares which are completely filled, just consider them as 1 square centimeter, because this is the squared paper where all the squares measuring 1 centimeter length and 1 centimeter breadth So that is why if the square is completely filled like this, then such square is considered as one full square, and the measurement of the area of this square will be 1 square centimeter. Just look at here, this is the square which is not completely filled, which is exactly filled half. So such squares are considered as half square centimeter. When you look at this square is not completely filled, but which is filled more than half, right? So still this square is considered as 1 square centimeter. But when you look at this square is not completely filled, but which is filled less than half. See here, this square, just look at the square I am showing you. This square is not completely filled, but which is filled less than half, means very negligible. So such squares are ignored, such squares are neglected. So consider the full squares first and half squares, and next the squares which are filled more than half. So the full square is considered as 1 square centimeter, and the square which is filled more than half is considered as 1 square centimeter, and the square which is filled exactly in half is considered as half square centimeter. Now let us count the squares. So 1, 2, and as I said, it is filled more than half, so it is 3 and 4. So what is the area of this closed figure? Because these squares are not completely filled and which are very negligible, which are looking like filled less than half. So that's why this portion and this portions are neglected. Only the squares are considered. Those are this 1, 2, 3, 4. So area of this closed figure is 4 square centimeter. And let us find the area of this shape. So I am going to count the squares which are completely filled first. 1, 2, 3, 4, 5. Next I am going to consider the squares which are filled exactly half. So this half and this half will give me one more, that is 6, and this half and this half will give me one more square, that is one more, that is 1. So 1, 2, 3, 4, 5, this half and this half 6, and this half will make one more, that is 7. So area of this circle is 7 square centimeter. And when you look at this triangle, so I am going to count the number of squares which are completely filled first. So 1, 2, 3, and this half will make one more full square, that is 4, and next it is half. So 1, 2, 3, this and this will make 4, and this is half. So area of this triangle is 4.5 or else 4 and half square centimeter. So in this way you can find out the area of closed figures just by placing those figures on squared figures, because these figures have no particular measurement. So that is why you can place them on square paper and you can count the number of squares which are enclosed by these figures. Find the areas of these two closed figures. So this is the first closed figure and this is the second closed figure. So let's begin with this. So as I said, we have to follow the common method in order to find out the area of these two closed figures. So let's begin with this closed figure first. So first count the squares which are filled completely. So the squares which are filled with the green color are completely filled squares. So just count them first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 squares which are completely filled. So just write them aside. Next thing, we need to count the squares which are filled more than half. So which are filled with yellow color. 1, 2, 3, 4, 5, 6 and 7. So 7 squares are filled more than half. So that's why they can be considered as 7 square centimeter. So just write it as 7. Now count the squares which are exactly filled half, so which are in pink color. 1, 2, 3, 4. So there are 4 squares which are filled in half, so that's why you can write them like this. That is, there are 4 half filled squares and which are in pink color. So how to find out the area of this? Just get the total of this. 18 plus 7 and 4 half will make 2 full squares. See here, this half and this half will make 1 full square. This half and this half will make another full square. So that is why 4 half filled squares will give you 2 complete squares. So that 18 plus 7 plus 2 will give you the total area of this closed figure, that is 27 square centimeter. Let's move on to the next closed figure. Now I am going to find out the area of this closed figure. So first I am going to find the squares which are completely filled. So 1, 2, 3, 4, then 5, 6. So there are 6 squares which are completely filled. So now I am going to find the squares which are filled more than half. So 1, 2, then 3, next 4 and 5. So these are the squares which are filled more than half. So just write them aside. Next, exactly half. 1, then 2, 3, then 4, and let's take this one as the half. So 5. So there are 5 squares which are filled exactly half. Then how to find out the area of this closed figure? So simple, just get the total of these squares, right? So we write 6 as 6 because there are 6 squares which are completely filled and there are 5 squares which are filled more than half. So that's why just consider all those 5 squares as 1 square centimeter. So we written as it is 5. And what is the half of 5 squares? So half of 5 is 2.5, or else the 5 squares, the 5 half filled squares will give you 2.5 squares. So just get the total of this now. So that is 13.5. So area of this closed figure is 13.5 square centimeter. Okay children, now let us learn area of some closed figures using formula. So we have our first shape, that is a square, and square has all the sides equal, namely each side is named as by the letter S. So we can show that S 4 times. And we have another figure beside square, that is rectangle. So in rectangle we have 2 sides equal, they are known as lengths, and we have another 2 sides which are equal and we call them as breadths. So breadths are usually shorter than 2 lengths. Now let us see how we can form the formulas for both the shapes. Dear children, to find out area of square as well as rectangle, we usually multiply 2 dimensions. Dimensions are nothing but measurements. So here we are going to multiply 2 dimensions of square. Those are S and S. And in the same way, we are going to multiply another 2 dimensions of rectangle. Those are L and B. So that we get the area formula of square, that is S into S, and we get the area formula of rectangle as L into B. So these are the formulas we can use to find out the area of both square as well as rectangle.